Okay, I think let's start, huh? So previously we saw this greedy best first search, and you have seen that we have only one cost here in the uh, greedy best first search. And we were using only one cost, or you can say we were using only one value that was given to us uh, in the form of a heuristic function. That was, for example, here the heuristic function was straight line distance values, which are given to us into the form of tables. And these are the actual values which are given between the cities on the map. Anyhow, we used these values in the table in the greedy best first search. And whatever the smallest is, we, for example, from this array, there are three nodes which are expanded. We select which one, which is the minimum, huh? Which is giving us the distance more close to the goal node. That was the approach of the greedy best first search. So now we are moving towards A star search. Normally, A star algorithm is available in advanced analysis of algorithm if you will go. So all these algorithms that you are seeing is also available in the course of algorithms, but not in fundamentals, but advanced analysis. Anyhow, here in A star, we are going to say that we will expand only cheap nodes. Cheap node. What is meant by cheap nodes? We will see. So in this A star search, we will expand which node, or we will select and then we will expand in the tree which node. For example, here you are saying arad is selected, and then from arad 3 are now expanded, but which one will be selected? For example, here it is selected. Why? Because we want to expand only the cheap nodes. But what is meant by cheap nodes? Let's see that. Here in A star search, we will use a evaluation function, and the name of that evaluation function is f of n. In the greedy best first search, we were using a heuristic function that was straight line distance function. Huh? And here, which function we will use? We will use an evaluation function. In greedy best first search, evaluation function was straight line distance values. And here, the evaluation function is what? F of n. And f of n is what? It is a combination of two things, g of n plus h of n. G of n is what? G of n is the actual values that are available on the map. Okay, up to some node n. For example, where is the map? For example, here. Here, what is the G of n of Sibiu? And then you can say from Arad to this is one, this 140 is G of n. If you are going in this, one person can say that the from Oradi to Sibiu, what is the G of n? 151. From some other node to that node. So I am looking at this node, which is also the path is coming from some other node. So that is representing G of n. Okay. So now G of n is clear. But what is this H of n? H of n should be the estimated cost towards the goal or to the goal. From where? From some node n. From some node n. So from some node n, estimated cost towards the goal would be called H of n. And H of n mean heuristic function. So in this A star search, you are going to use the actual values which are available on the map. And the other thing is, you are going to use a heuristic function also additionally. Additionally, you are going to use a heuristic function. And in the previous example, we have a heuristic function that was straight line distance values. Hmm? So we are going to use those straight line distance values and the actual values available on the map. We are going to use them together. And f of n is what? It is an evaluation function, which is the addition of these two things. Okay, now we have two things. We can add them and we have our value for the f of n for each node. Anyhow, how you can say that what is f of n? Okay, f of n is our evaluation function for the A star search. But here, the actual definition is what? F of n, the value of f of n will represent the estimated total cost of the path through n towards the goal. Path which is going towards from some node towards the goal. From node n through, or you can say through node n to the goal, the total cost of that path would be called, not that final path, oh, whatever it is representing. If it is representing a part of the path, then f of n is what? It is an estimated total cost of that part of the path. And if it is representing total path, then it would be the estimated cost of the total path. Anyhow, you will, the main understanding is with the g of n and the h of n. And g of n is what? The actual values which are available on the map. And h of n is what? The heuristic function that you will use and through which you will get those values. You have to add them. And then in the search, when more than one nodes will be expanded, which node you have to select for further expansion? You have to select that node which will have the lesser value for the f of n. And when you will always select a lesser value for the f of n, that is how the A star search will go on during its processing. So let's see this example. And here in this example, you are seeing that we are going to start from the Arad for the Romanian problem. And initially, g of n for the Arad is what? At Arad, you have not covered any distance. So that's why you are standing at the starting position. So when you are standing at the starting position here, if you are standing here, you have not traveled anything. So your distance is 0. So that's why g of n of Arad is what? 0. Plus h of n of Arad is what? You have to look into here. For example, h of n is straight line distance value. So the value for the Arad is 366. So 0 plus 366 and a final value of f of n would be what? 366. This is how you are going to calculate f of n for each node. And then you have to decide that which node has the minimum value for the f of n. Then you have to select that minimum and then you have to expand it further. So anyhow, here, so 0 plus 366, you are seeing 366 here. Okay, you have calculated, it is only one. The algorithm will do what? It will expand all the nodes according to the map which are given there. And 3 nodes are given there, Sibiu, Timisoara, and Serin. Now the algorithm will do what? It will calculate the f of n. F of n by how? By using this formula. And this 140 is the g of n. And 253 is what? The h of n. So Sibiu 140. We are coming from where? We are coming from Arad. From Arad to Sibiu, what is the actual value? What is the actual value of 140? From Arad to Sibiu, actual value is 140. 140 plus this Sibiu. Okay, look into here. And Sibiu is 253. So you have to add them. When you will add, you will get this. Similarly, you will do this for Timisoara and you will do this for Serent. So you are looking at the map and also the table. And the table is representing your h of n. Okay, when you have calculated all these values, then the algorithm will select which one? The minimum one. 393. This is 447. This is 449. So 393 is the minimum one. Minimum value of the f of n. So algorithm will select that and it will expand all the nodes which are available again on the map. And from CPU, there are 4 nodes available on the map, and which is what? Arad, which is going backward, Fagaras, which is going next, Oradi, and Rimnikovilsia. And then you have to calculate their f of n. So these 4 and these previous 2 nodes are now existing on the frontier. And then you have to select which one from the frontier, again, which has the minimum. So which is the minimum here? Which node has the minimum value here? Maybe this 415, huh? Maybe this 415, huh? So, sorry, this 413 is the minimum. 413 is the minimum. So algorithm will select that and it will expand next. And it will calculate the f of n accordingly. And then these new 3 nodes and these previous 2 are on the frontier. Again, you have to select the minimum. And then minimum is what? This is 417 is new. And then 415 is the minimum one. That's why it is highlighted with this one. So that Fagaras will be selected and it would be expanded. And then f of n will be calculated. And after that, again, you will see which one is the minimum. Which one is the minimum? Okay, minimum is again this 417. So algorithm will select it. And from the map, what are the next nodes? Those nodes will be expanded. F of n will be calculated. And then which one is the minimum from all these frontier nodes? From all these frontier nodes, which one is the minimum? So this 418 is the minimum. It will be selected. And before expansion, there would be some condition. It is a goal. If it is a goal, return from the algorithm. Huh? Return from. So then here we are checking. It is a goal. Yes, it is a goal. And then what? Return from that. And here the G of n for Bucharest is value on the map is what? 418. And the H of n in the table, the value is 0. This is how a star search will execute. Yes.
Why we select France here? Why we not select from the new choice?
Here, why we selected this Fagaras here? Your question is what? Why we selected Fagaras here? Huh? Here. And why not the other one? Here the value is 415. This is the less value.
Not from the new choice.
Yeah.
All the nodes.
We have to select always the minimum one.
From all the nodes.
From all the nodes. Anyhow, this is not ended here. I have given you, normally I gave first the intro and then we normally have an example. Okay. And then from that example, you will understand that what is going on, because here we have an algorithm. So then I will execute that example according to this, statement by statement according to this algorithm. And then you will completely understand. Anyhow, if someone will give you the example like that, now at least without looking over the algorithm, you can execute that example, huh? Without looking over the algorithm. Now, this is another example, short example. Here, heuristic function is given, which is the straight line distance values again for the states A, B, C, D, which are here, A, B, C, D, and these are their values. And this, you can say a graph or a map, whatever you want to say, this is here. And the starting node is what? A. And in this example, goal node is what? D. And the values which are G of n, which are the actual values, those values are also given in this graph. And the objective is to reach at the goal D from the starting node. So according to this previous understanding, if you will start from here, if the algorithm will start from here, then what it will calculate? It will calculate f of n, huh? it will calculate f of n, which means it will calculate f of a. F evaluation value for the node A. That would be what? G of n plus h of n, which means g of a plus h of a. And the g of a for the starting node is 0 here. And h of a heuristic value from the table is 6. So you will write that 6. 0 plus 6 is equal to 6. So this is what you have here for, and after calculating, you will kept that node in the frontier in the list. And then you will select the minimum. Initially it is only one, so that would be selected. Okay, then selected, and then it will be expanded, and then it will be expanded. But now the point is, which one would be selected for next expansion? When it would be expanded, then their f of n will be calculated. How you can calculate the f of n for the B and the C? F of B, or you can say f of A from B is what? What is the actual value of the B from A to B? 1, which is here. And what is the h of n for the B, which is here, plus 4. So 1 plus 4 is equal to 5, you can say. And similarly, for this C, f of A to C, or you can say f of C. That would be what? Actual value is 5, which is written here. And the value from the table is 2. So 5 plus 2, it is what? It is 7. Okay, now these values are here. Now the question is, the algorithm now will select which node to expand according to the f of n. And in the f of n, how many nodes are available? 2 nodes are available, this one and that one. Which is the minimum? This value with the 5 is minimum. It would be selected. Value with the 5 is, it would be selected. When it would be selected, then it will be expanded next. Then it will be expanded next to D. So that's why you are seeing an F from A to B to C, this path. And for this, what is the value here? A to C to D, this one, second one. A to C and then D. So what is the value here? So this actual value is 10, which is mentioned here. And the previous value, here something may be wrong, A to C. Yeah. Just a minute, I have to do the correction and then we will come back. Okay, A to B to D. The D. First I am A to C to D. So this 10 and then for the D plus 0. 10 is the actual cost, No, we have to previously it is. No. For the minimum, we have to select this. This is with the 5. This is with the 7. According to the algorithm, it will select the minimum, and that would be 5. I can also say something like that. Yeah, the path is okay. The minimum is 5, so 5 would be selected. So then 10 or 15. I'm thinking of it. So I think 15. If I will say 5 plus 10, the total cost, if I will say 15 plus value from the table is 0. Yeah, the total path cost. Previous 5 plus 10. I'm just writing, Because I know that in the algorithm, we normally calculate the total cost, huh? But here we are not, here in this example, it is not considered. I'm looking at first why it is, okay, 5 plus 10. Yes, it is written correct. This 5 plus 10 means this 5 and the 10, okay? 15 plus 0. It is already there. No, 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 no.
Yes, from previous slide, we expand only the minimum.
Because the value is already there calculated. That is the reason. Don't worry, don't worry. Okay, I have to just correct it. A, C, D, yes. And then 5 plus 10 plus 0, that is okay. And then A, B, D, that is 1 plus 7, that is okay. Is and it gives us which one? Yeah, now it's okay. Okay. Now I'm coming back. Look over here. Previously, we saw that from A to B, we have this 5, and from A to C, we have this 7. So now we have corrected something over this slide. We have corrected the order, and also the values are almost okay. So previously, I said that from this node A, this B and C will be expanded, and their values are here. And then the minimum would be selected. According to the algorithm, minimum would be selected. Minimum is this one. 1 plus 4 is equal to 5, which is, so it means we are at B, huh? We are at B. So anyhow, so when we are at B, so then from A to B, and then this one would be selected and it would be expanded, and the next is 7. So then what? From A to B and the D is what? 1 plus 7. This one plus 7, that 1 plus 7 is written here. And the value for the D, H of n is what? 0, which is here. So this is G of n. This is H of n. And you have finally what value here? Maybe 8. Maybe I have to move it. After this, I have to move this statement down. Huh? And then from A to C and then to D, the other one, it is also calculated. Anyhow, this is selected. And then you will see in the algorithm, okay, D is a node. Yes, it is a node. And then you can go out of the algorithm. Yes.
We are expanding the least. Why did we start expanding the?
If we are expanding the least, then why would we have not continued with the, okay, this is written here because it is an example. We have calculated the values and shown here only and shown here. Okay. Only the values are displayed here. It doesn't mean that we are going according to the algorithm statement by statement. These, this is from the textbook, so that's why in the form of a tree. So that is something more clear, you can say. And this is an extra example. I have inserted it, and this text is written by me. So we will, if we will go according to the algorithm, then first with this, then these two will be expanded. From these two, which one is the minimum? This one is select. 5 is the minimum, which is B. So this statement will be executed. And then you can say, according to the algorithm, this will not execute. But it would be in the frontier. Huh? But so this will not execute, but it would be in the frontier. If the tree, if the search has to go forward next, if this is not our goal, then you have to calculate it. So this is only for your example, for your practice. It is written there that from A to C and to D, And if we will go from here to here, then this is the 5 and the 10. You can write it directly 15 here. And then plus the h of n, which is for this 0, and it is giving us 15. This statement is written there. So that's why now you can compare them in your mind, and then you can say, okay, this is the minimum. Huh? This is the minimum. Here in this, so finally, here in this example, and here in this illustration, we are not going according to the statements of the algorithm. We are just executing the statements that in this algorithm, this will happen, and we will reach here from A to B and to D with this cost. Huh? And the B, which has the least cost, or you can say which has the least value for the f of n, that B will give you the best path, or you can say it is the goal. Now, we are taking this same example here on this algorithm, and then we will try to understand this algorithm statement by statement. But before that, let's have a look over this algorithm so that when we will execute, then you will know that which statement is where. So for example, this statement 1, put node start in the open list. So there is a queue that is called open list. Huh? So put node start node start mean initial node, starting node. Put that node into the open list with this value f of node start is equal to h node start. So if I will write open here, which is for the O for the open, huh? Or I can write it like that, huh? Op for open and put node start. Starting node here is what? A. So I am putting that A here. With this thing, f of node start, which means f of A, is equal to h of node start, which means h of A. So what is the h of A in the table? H of A is 6. So that 6 will go where? That 6 will become the value of this one, h of A. And maybe I have to write this op here because I want to write some value down and also some values. And initially in the open list, we have the A and the h of, this is f of n. F of n is calculated for this value because g of n is 0, so that's why it is not mentioned. Huh? G of n is 0, so that's why here it is not mentioned. Otherwise, g of n plus h of n. This is the formula. Huh? This is the formula here, but g of n is not mentioned. So that is the similar question that you did in the previous, on the previous slide, why that is thing there. But now we are going according to this algorithm anyhow. So h of n is what? For the A, it is 6. So I am writing that 6 here over the node. And then we have this while loop. First read it. While the open list is not empty. Okay. This open list is not empty, and then this bracket is starting. And then this bracket is going where? This is the bracket of the while loop. Maybe this is the loop. This is the ending bracket of the while loop. Okay. And then we have, I'm just reading first. Take from the open list the node current with the lowest f of n. This means f of n. And then here you are adding g of n plus h of n. So from the open list, you have to take some node out, but according to which criteria? According to this f of n. So you will calculate this f of n and then you will select the lowest one. Huh? Whatever the node which has the lowest f of n, you have to take that from the open list. And this is the thing that we talked on the previous slide, that which node we will select, which will have the minimum value of the f of n. And here we are calculating that f of n, and then we are selecting The minimum one. Because, and then we are selecting the minimum one. Anyhow, now the next. This bracket is still going on. If node current, when you will select, that would be your current node. And then current node is the goal node. If it is goal, okay, we have found the solution, and then break this while loop. Break this while loop. This break is written there. And when it would be breaked, you will come here maybe. Huh? You will come after this bracket. Anyhow, next, generate each state node successor. Node successor means next nodes. So generate each state node successor that come after the node current. So after your current node, whatever the next nodes are, generate all those next nodes are successor nodes. Generate them. You will generate here at this step. And then what? Then we have a for loop. For each successor, which means for each neighboring node, which is coming next. For each node which is coming next, for each neighbor, you have to execute this loop. For each node successor of the node current. So whatever the successors or neighbors of the current node is, you have to execute this for loop for each of them. And then we have its bracket started for the for loop. And where it is ending, let's see, I think this is the end of the for loop. This is the end of the for loop. And then we have next statement, set successor current cost. We are calculating some type of value, some type of cost. And how we are calculating? G of n, which means this is G of n, which means whatever the current node is, take the G of n from the map, take the value from the map, plus, and here we have W for weight. W for weight of weight. So this is the value from the map, and then weight W, which is weight from current node to the neighboring node. From that current node up to the neighbor, what is the weight on the map? Okay, you have to see again on the map. What is the weight? What is the value there? So you will see that value from here, and then you are adding these two values and putting that value here in the successor current cost in this variable. So this variable is successor current cost, or you can say the current cost of the neighbor. Okay, after that, we have an if condition, node successor is in the open list, and then we are checking that this neighboring node that for which we are executing this for loop, if this neighboring node is in the open list, we will check this open list. If this neighboring node is in the open list, if this condition is true, then we have to execute this thing from this bracket to this bracket. And what is that? Then here we are seeing that the if G of the neighbor node successor, yes, G value on the map, G, if the G value of the successor is less than or equal to successor current cost, this cost that you have calculated, if it is like that, if this condition is true, continue to line 20. We will jump to this line 20, which is this one, which means you don't have to execute anything, and here ending bracket of the for loop. So control will come here, and then again the control will go to this loop for the next neighbor. For the next neighbor. Why I am reading first? So that you will have the understanding of the structure of the algorithm. And then after that, here, after this if, we have this else if, and then here we are checking the node successor. If it is available in the closed list, so closed list, you have to make a closed list also. Initially, okay, we don't have anything in the closed list. So you have to check that if this neighbor is available in the closed list. If it is, if the condition is true, this is the starting bracket, and here it is ending. If it is available in the closed list, then you are checking the G of this successor, the G cost of the neighboring node. for which this loop is going on. And then if it is less than or equal to successor current cost, which is this variable you already calculated here, if this condition is true, continue to line 20. And then you will again move to this line 20 and then again to the for loop until it is not ended. Until it is not ended. But if this condition is false, if this is also false, then you will come to this move statement. And here moved, you will move this successor node or the neighbor for which you are executing this for loop from the closed list to the open list. You will move from here, you will remove it from here, and then you will move into open list. Okay. And then we have an else and starting bracket, ending bracket. So if these two ifs will not execute, only then this else will execute. And here we are adding this neighbor for which you are executing this for loop. You are adding this neighbor to the open list. Okay, open list we are adding. And then we are calculating the h of n for this neighbor. H of n, heuristic value. Set heuristic value to be the heuristic distance to the goal. And then you will see set h of n to be the heuristic distance to the goal. So you will see the value from the table for this, and then you will set that value here. Maybe, for example, this is the heuristic for this. Similarly, if some other will come, you will set some value here up above. For here discussion, we will set that value here up above here. And okay, so this statement, in this statement, we are calculating the h of n for that neighbor. And then, okay, this is the end of this else. And after that, you will come here. Here we are setting g of n for that neighbor. G node successor, whatever the neighbor is coming here through this loop, we are setting the g of n. From where we will set, we already calculated its successor current cost here. So, and here it is written, we are just updating that value. Now h of n of g of n both are there, so we can calculate f of n, no issue. And now set the parent of the neighbor or successor to the node current. And then we will draw the tree like that. We are setting the connections. And after, okay, this is the end of the for loop. In this way, it will go on for all the neighbors. When all neighbors will be finished, we will come here. And then we will add this current node to the closed. We will add, after that, we can add something here.
What does the wait mean again?
When I will run it, then you will see, okay. I'm not running it. I am just reading it first to get an idea of the structure of the algorithm. And when this while loop will end, either this while loop can be ended when the open list is empty or when it will be break, when it will face a break here. And then when it will break, then here we are checking if the current node is not equal to goal. Then if this not equal to goal, then exit this algorithm with an error that the open list is empty. This is the message. And now, after reading this, we are going to run it now. And here I am writing for due to that first statement, put starting node in the open list with the f of n is equal to h of n. Okay, starting node is A. I am putting here in it. In this illustration, I am going to write my normally. Anyhow, with f of n is what? At of node start. Starting node, what is the value for what is the h value for the starting node? H value from the starting node is 6. So then, so h of n is what? I am writing that h of n here at the top of the node. So this is, by the way, for this is also my f of n and also my h of n. And then I am going here. Open list is not empty. Yes, it is not empty because we have a node here. And then we are here and take from the open list. a node with the lowest f of n, with the lowest f of n. And f of n means g of n plus h of n. So initially I have only one, so I will take it out. I will take it. Initially I have only one. So what I will do, I will take it out. So anyhow, g of this a is 0, initially. Initially, g of a is 0. And h of a is what? H of a is from the table, which is 6. So that is 6. So 0 plus 6, we have this 6, which is written there. But anyhow, initially it is only one node, so I don't have to compare. So I will take it out. But how this algorithm will take it, it will take out like that. It will calculate the f of n of all the nodes. And then whatever the minimum is, it will select that. But initially I am in the beginnings, I have only one node, so that's why I'm taking it out. And then, so now node current. So my node current is now A, I am writing it here. So my node current is, so this A is a goal? No, it is not a goal. So condition false, I will come here. Generate each successor node or node successor that come after node current, which means A. This is A. A node current means A. Generate each successor node. Generate each next node. So each next node is B and also C. These are the two next successors of A. So I am writing here that here it will be generated B and then C in this statement. And then for each successor node of current node. So these are the successors, and this loop is executing for each successor. Yes, for each successor. So then what? I am writing this BC again, because this loop will execute two times, one for B, one other for C. So initially it is executing for B now. I am just, I have a stroke over it so that we will remember it that we are executing it for which node. So for B, we are executing it. So for each, so now my node successor is what? My node successor is what? B for the first turn. And then here I am calculating G of node current. My node current is different. My node current is what? My node current is A. Okay. So G of A, initially G of A is what? 0. Initially that is 0 plus weight. W is what? Weight. This is your question, plus W, weight. Node current. What is the weight? From node current to node successor. From A, node current means A, node successor means B. From A to B. From A to B. This is the weight. This is the weight. So that is 1. So that is 1. So 0 plus 1, and you have successor current cost 1. Successor current cost 1. Understood? Up to this point. Successor current cost is 1. And then I am here. If node successor, which is B, is in the open list, no. So this condition, if condition is false, and I will come here, else if this node successor, which is what? B. If B is in the closed list, no. So I am also writing my closed list here with CL. And initially, for example, it is empty. So this condition is false. So I will come here in the else portion. And here, add node successor, add this B to the open list. So that's why I am now adding B here in the open list. And then, so now this is done. And now this set heuristic of this successor, which is B, set heuristic of HB to the heuristic distance to the goal, So heuristics are given here. What is the heuristics for the B? 4. So set that value here. So I will write that value up above the B. Huh? Now it is set. Huh? Now it is set. Okay, now this bracket is ended. And this was the bracket for what? This if starting here, ending here. This is for the for loop. Yeah, okay, for the for. Then I am going back. Huh? If it is for the for loop, okay, then I am going back. Why? This is okay. This is not the end of the for loop. Sorry. I don't have to. If you will look over here, this is not for the for loop. Yeah. I don't have to follow your instructions, huh? So this bracket is this is the end of this bracket. So it means still for loop is going on. Huh? So this is not for the for loop. These two statements are this is the end of the for loop. This is the end of the for loop. So it means I will come here to this set, huh? And then set G node successor. G of successor is what? B. So G of B is equal to what? Successor current cost. And that current cost, I have calculated it here, which is already 1 mentioned here. Set G node successor. This successor is what? Here it is B. Is equal to what? Successor current cost. Successor current cost is already calculated here, which is what? 1. So that 1 will go here. And I am writing that one here under this. So this top value is representing H of n. This is representing G of n. So now the value of the G of 1 is now set. And then set parent of the node successor to the node current. Okay, if you want to draw a tree, we have started from the A and then set parent of the node successor. So node successor is what? B. So I can say, okay, this is the B and then set it. And this is what it means, huh? Which means draw like a tree in a parent and child format. Huh? So this statement is executed. Now this is the end of the loop. This is the end of the for loop. And now I am going here to this for loop. And now I will execute this for the C. For the C. This for loop for the C. And here G of node current. My node current is what? A. And for the A, G is still 0. Okay. And the weight from A to C. Now this successor is C. From A to C, what is the weight here? From A to C, the weight is 5. So 0 plus 5. Now here 0 plus 5 is equal to 5. We can say now it is 5 and we can remove it. And we have this value here. Successor current cost. So now successor current cost is what? 5. And then I am going next. Node successor, which is C, is in the open list? No. And then I am going to else. If node successor, which is C, in the closed list? No. Then I am going to this else portion. Add node successor, which is C, to the open list. And then I am adding this C here. And set the heuristic value for this C. Okay, what is the value? Heuristic value 2. So I will set that here. After looking into the table, I will set that value here because this top value is for the heuristic. And then, okay, this is end of the else. And then I will come here. Set the G of C with this successor current cost. Successor current cost we have calculated 5. So this will be updated for the C. And that would be what? 5. I am writing that 5 here. And then set the parent of the node successor to the node current. Node successor is C, node current is A. So then, okay, I'm drawing that C and we are setting with the parent. And then I am going again to this for loop. And here both of the neighbors or successors are finished. So this loop will be ended. Huh? When this loop will be ended, I will come here. Add node current to the closed list. Node current is what? A. Add this A to the closed list. Okay, add it. So now the story of A is finished. So that's why it is in closed list. Huh? Okay. And now when you after that, this is the ending bracket of the while loop. So I'm going back again to the while loop because it is not finished yet. So and then here I'm checking open list is not empty. Open list is not empty. Yes, it is not empty. We have two nodes there, B and C. And then take from the open list any node with the lowest f of n, and f of n has this value g of n plus h of n. And now g of n and h of n are already there. Huh? So you can say it is calculated, or the algorithm will calculate it. So 4 plus 1, 5, and 5 plus 2 is 7. You have to select the minimum one. So which one is selected? This B would be selected. Huh? So this statement, these statements will give you what? This would be selected. Which is which has the lowest value. And then here, if node current is the goal, so this now our node current is what? B. You have now it is updated. Node current is what? B. So now B is the goal node? No, it is not. So then I will go next. Generate each successor of this node. And for the B, what are the successors? Only one, which is D. Only one. So then what? How many successors are there? How many successors are there for this node? Only one, which is D. So now this loop, for loop will be executed. I am removing it. I think maybe this eraser will work. I don't know. Yeah. But it is taking time, huh? If I will erase it through one command, then everything on this slide will be erased. So that's why I'm taking care. I don't want to do everything will be deleted. Okay, and then yeah, good. These are the students. Thank you. Now it is easy. Otherwise, it's better to remove. I have done that, huh? 0, 6. This. Thank you. You saved my time, huh? Okay. So now I was here. Take from the open list, and we will take this B out because it has the minimum using this f of n. And now our node current is what? B. Our node current is what? This B, which we have removed. And it is not a goal. So that's why this condition is false. We will go next to the next, generate successor nodes for this node current, which is B. Successor node in the diagram is after B, we have only one, which is the D. And this is our starting node, we know that, and this is our ending node. We know that from the previous slide. And now for each node successor of the current node. So current node is B and successor, and we have only what? We have only successor, we have D. We will execute this for loop only for D. And then here, G of node current. G node current is B. G of B is what? G of B. So G of B is what? It is 7. It is what? 7. So, okay, if I will write this 7, I don't know. This 7 plus weight, node current. Node current is B to the node successor. To the node successor. Sorry. Node current. Node current is B. G of B is what? G of B is 1 actually. G of B is 1. Nobody has interrupted me. Huh? You have to interrupt if I will do some mistake. So this is 1. G of B is what? 1 plus weight node current, which is B, to the successor, which is what? D. So from B to D, what is the weight? That is 7. That is 7. So 7 plus 1 is equal to 8. Now you have this value, successor current cost. And then you are checking this node successor, which is this D, is in the open list? No. Then condition is false, and then I will come here. Else if this D is in the closed list? No. And then I will move here on the else portion. And here add this node successor, which is D, to the open list. So that's why I'm adding this D here. Set the heuristic value for this D. Heuristic value for this D is what? 0. I am writing 0 here. And then this is the end of the else, and then I will execute these two. Set G of n for this D. And how? Through this value, which is this 8. We already calculated here, which is 8 here. So 8. So I am writing that 8 here. And then set parent of the node successor to the current node. Okay, parent. Current node is B, successor is D. Okay, set it. So I am writing that D here. And then now it is set. This is the end of the for loop, and I will go there. There was only one successor, which is finished. So for this for loop is ended, and I will come here to this statement, add node current to the closed list. And now I am adding this node current. Node current is what? B. Node current you can see from here with the strike line. Huh? B. I am adding that B here in the closed list. And then while loop is ended, and I will go there to this open list again. Open list is not empty. Yes, it is not empty. Still we have 2 nodes. And then take from the open list with the lowest. This is 5 and 2, 7. This is 8 and 0, 8. So this is the lowest. I will select that. I will select what? C. So now my node current is what? C. And then if this node current is a goal, no, it is not a goal. And then generate each successor. What are the successors? From C to D in the graph or map, it is again D. It is again D. So for now, again, for loop will be executed only for once, and that is what? The D again. D again. I will write the D here, and I will strike it again. And then here we are calculating the value G of node current. Node current is C. C, what is the value of that? G is what? 5. So that 5 plus weight from node current to successor. Successor D is D. Node current is what? C. So from C to D, what is the weight? From C to D, what is the weight? 10. So that 10 here. So that 5 plus 10 is equal to what? 15 here. 15 here, which is successor current cost. And then if node successor, which is D, is in the open list, yes, it is in the open list. Huh? Here, my node successor is what? D. My node successor is what? D. D is in the open list. If you will see open list, yes, D is in the open list. Condition true. When condition true, I am executing here. I am executing this statement. I am checking if G into node successor. What is the G of node successor? Node successor is this D, and the G is what? 8. Is G is what? 8. Less than or equal to successor current cost. Successor current cost, which we have calculated here, 15. So 8 less than or equal to 15. Condition true. Condition what? True. 8 less than or equal to 15. Condition true. And if condition true, continue to the line 20. So then I will go to this line 20, which is this one. I will reach here. So all this thing will be skipped. D is already, yes. Continue. Yeah, it doesn't mean here in the algorithm, continue to the line 20 means go to the line 20. I don't know, normally in old ages when we were studying C or C++, there was a function there, go to XY. I don't know it is available now in the programming languages now or not, huh? Anyhow, so which means go to XY, we will write the line number and then the control will shift from there to that line number, okay? So here continue means that. By the way, where here on the line 20, it is ending with a bracket. So it means skip the remaining body of the loop and go to the next iteration of the loop. This is the meaning here. Here, according to the statements, the meaning is skip the remaining body or the remaining statements of the body of the loop and go to the next iteration. Huh? This is what it means here. So continue to the line 20 and okay, here I am here and then I will go back again here. And there was only one D. So this loop will not execute next, huh? Because we don't have any successor. And then this loop will be ended. And here, when it will be ended, we will be here. Add node current to the closed list. And we are adding this C into this closed list. Into this closed list. What happened actually? Here, the successor current cost is 15. Previously, we have this successor with the less cost 8 already there. So that's why it is no need. There is no need to go with the highest one. So anyhow, this is now, and now I am here. Bracket is ended, which means I have to go back to this while loop. And here, open list is not empty. Yes, it is not empty. One node is there. Take from the open list with this f of n, g of n plus h of n. Okay. Fortunately, we have only one node, so we will select that. Huh? Otherwise, you know that what is the selection criteria. So we will select that. And then here, my node current is now D. D is a goal. Yes, it is a goal. D is a goal node. Yes, it is a goal. Okay, we have found the solution and break the while loop. So when the while loop will be broken here, and then I will come to this next statement, and here I will check if node current. If here, when it is not, my node current is now D. So if node current, which is D, not equal to goal, not equal to goal, it is goal, okay? So this condition is false, not execute, and we already have said that we have found a solution and break. So now, and then if we have something next, we will go there, which means we are going out of this function. Huh? Yeah, if we have not, somehow if we will reach here and that is not goal, only then this if will be executed. And here we are executing that if it is not becoming true, but we are executing. Anyhow, that is not an issue. You can simply write a return here, huh? And you don't need that. This is just an algorithm. The main the main things are something other, not this condition, huh? So this is how the A star search algorithm will run. Yes.
When you have the second step, you set the value is 15, so no need to update the.
Yeah.
What if we have small things like 7?
Then that will be updated. Yeah, this algorithm will update it.
It cannot be the same pattern in the same order, that be 8 to 7.
The first thing is you, now this the value here is larger than the previous one, that is why it was not executed. And the first thing is that this second value is not possible to be less than this, because algorithm is always selecting less value. It will select the less value first and larger value after, as you are seeing here. What is your question? The other part?
Like, if we get two values, different values for the same alphabet, we can't have it without it, right?
Yes.
Just having one of them, the smallest one.
Yeah, the smallest one. The algorithm will select that automatically, and then it will add into the open list. Anyhow, adding open list is like a frontier, huh? And this closed list is like a explored set, huh? Your previous terms in the algorithm, there was a frontier, there was an explored set. So this is frontier, this is explored set. So here, if we have some larger value, the algorithm will not allow, because here we are doing something with the less, huh? Always selecting the lowest, huh? By that order, I am saying it is not possible. But suppose if it is possible, then in the open list it is possible, but that will be updated again. That will be updated again here with these if, else if, these two conditions are for that matter. Huh? Any other? Just a minute. Yeah, Arabic. अरबिक कोड इंग्लिश से नहीं पढ़ा अच्छा नहीं पढ़ सकते 09 Now, what is your question? After calculation, find something like 7 to 8 and 5. Same values for of g of n for what? If you open this, for example, the C and D, we are having 5 and 8, right? For C and D. Yeah, on the open list. For C, the value of g of n is 5, and for D, the value of g of n is 15. Up there, where? Here? Yes, here.
the open research world.
This one, that one, which one? This one?
Yes, it is possible to have C7, D7, something like that.
C7, D7. I think if this is the G of n, C7, D7, how it is possible? It means that B is now the 7. If there is a path, it means that path has a value 0, only then it is 7. So don't go into that details, okay? In real life, from one point or from one city to other city, normally, can you say the distance is 0? Then why you are thinking here 0? No, we have not taken any. Even in the previous algorithm, we said that this distance value must be the positive value, okay? And that positive value means 1, 2, 3, 4, 5, something, okay? So you will have 7, 7 only when previously, if one of the edge next is 0, only then. Otherwise, it is not possible. Otherwise, it is not possible. If, for example, this was the first uniform cost search, huh? Which was, if you remember, huh? Something like that, huh? Why are we not saying 0 or minus or something? Why you are thinking in that way, okay? You don't have to think in that way because here we are saying also here that the step cost should be greater than or equal to epsilon. Epsilon means greater than 0, must be positive value. We already said that. We have this concept already in that algorithm. The reason is, if you will think 0 or the negative, then you will go into the wrong direction, okay? Then you will not get the optimal result from the algorithm if you will think 0 and negative. If you want to think, okay, think and calculate your values with the negative. Okay, do it. Waste your time. But the algorithm is saying you don't have to take those negatives or 0 values. The same concept, this is the same concept going on in all these algorithms. And we are here. So here 7, 7 only possible if you will take the next edge 0. Only then. Otherwise, it is not possible. Moreover, if you will take 0, you are going against the definition of these algorithms. You are not taking positive values, huh? Clear? Oh. So where this A star search searching algorithm, where we are, sorry, I have to start it. So now it is ended and we are here, A star search in games. So we can use this algorithms also in games, as this algorithm is already in use for this game, which is tower defense games. I have provided a link here. You can click over it and you can see. The other most popular game is this Warcraft. And behind this game, A star search algorithm is in use. This is just an idea that we are using these algorithms we can use it for different purposes. And here, these are the 4 things of the A star search algorithm, which we have to see: completeness. So is this algorithm complete? This A star search algorithm is you can say, most updated algorithm that we have seen so far from that beginning, from our beginning algorithm. This is the most, you can say, a little bit lengthy and updated form of algorithm from your previous algorithms. So it is complete. Complete means when some solution is available, it will give you or not. Yes, it will give you that solution unless you don't have infinite nodes in the same condition. For the previous algorithm, we have always said that mostly the algorithms are complete until we have the state space infinite, loopy paths or whatever. So if your space is finite, it is complete. A star search is a complete algorithm. It will give you the solution. And then time. The time complexity of this algorithm is order of b raised power epsilon m. And what is epsilon here? Epsilon is equal to this. M is okay, the maximum branching, maximum depth of the, something like that, depth of the state space. Huh? And then epsilon is what? Epsilon is h star minus h divided by h star. And here h star means optimal heuristic function. And here h means normal heuristic function that you have designed for your algorithm. In previous algorithm, we said straight line distance function is a h of n. We said straight line distance is what? Is a h of n. That was our h of n. Similarly, for a star here in this algorithm, straight SLD is again our h of n. This formula is saying that, and this epsilon is what? It is a relative error. It is showing what? It is showing relative error. So this epsilon is the value of some error that you are multiplying here with this m. But how I can evaluate this error? I said h star is what? Optimal heuristic function that you have built for your algorithm. But normally it is not. But anyhow, and this h is what? H of n is what? Your normal heuristic function that you have built for your algorithm. If your normal h of n is performing like an optimal heuristic function, then this h will be equal to h star, which means your normal heuristic function will behave like optimal heuristic function. Huh? Are you understanding this mathematical notation? Here, this mathematical notation is explaining what? When your heuristic function that you have designed for your algorithm, if it is behaving like h star, optimal, best of best, then this h will become equal to h star. And then if it will become equal to h star, then h star minus h star 0. And then this epsilon will have this value 0, which means zero error. Huh? This is what it is giving you the understanding. That if you have designed a good heuristic function that is like optimal heuristic function, then this error will be 0. Otherwise, and if you're this h of n, if you're this heuristic function here, if it is 0, you don't have any heuristic function in this A star algorithm. In this A star algorithm, you don't have this heuristic function. Here h is equal to 0 means you don't have any heuristic function in your h star. And if it is, this h star will be cancelled with this. Epsilon would be 1, the maximum value for the error. And then this A star will behave what? It will behave like uniform cost search. Okay, giving you, then this A star will be like uniform cost search, UCS. If your h of n is, if your h of n, if your heuristic function is 0, then you have the maximum error. And then this algorithm will behave like uniform cost search. Space complexity, order of b raised power n, the same as you have for the UCS. Huh? So all these things, complete time space is like UCS. Huh? Mostly things are like UCS. Is this a optimal? Yes, it is optimal. It will update it is going with the least value. Huh? Moreover, this algorithm A star will expand all nodes with evaluation function value less than equal to C star. C star is the cost for the optimal solution. And if the cost of the optimal solution is suppose 50, then A star will not expand any node with the cost greater than 50. It will expand always nodes cost less than 50. This is what it means, huh? Less than or equal to 50. It will expand always nodes with cost less than or equal to C star, and it will not expand any node which have the f of n value greater than C star. For example, here, here, this is the optimal answer, Bucharest 418. Huh? Now check all these previous nodes in the previous step. No one node is expanded, selected and expanded, which has the value greater than this. 418 is the C star, cost of the optimal solution. Huh? This is optimal solution, Bucharest. And the cost of it is 418. And then the previous, it is coming from Patisti. What is the Patisti value? What is the value for the Patisti in the previous step? 417, less than, huh? And check some other nodes. Okay, this one Fagaras, 415. This one Rimnikul Vilsia, 417. This one 393. So all are less than this 418, less than or equal to. That is what that condition means. A star will not expand nodes with f of n greater than C star. Greater than C star, not expand. It will expand always less than or equal. So I will upload the quiz on the Blackboard, okay? I'm not wasting my one lecture with the quiz. Huh? I will upload your quiz also on the Blackboard, and you have to answer it by filling it and by writing it, whatever you want to do, as you normally do with your assignments. You have to do the same with the quiz, and you have to upload it on the Blackboard, which I will mark there. And yeah, there would be for assignments, I normally do not. This time I didn't strict the assignments with the deadline. Deadline is there, but submission is allowed even after the deadline. And if you will do that, I will get the notification that it is late submission. I will deduct some marks from your total. But for the quiz, maybe I will not give you further time, okay? If I will give you some deadline, that would be final. And after that, you cannot submit anything, okay? Okay, so for quiz, I have to be a little bit strict, huh? So if I will do that, you have to be uh, careful. And when I will upload it, you will get the email only. So always try to configure your email accounts on your mobile phone so that you can get the notification on. If you have the WhatsApp group, I will also share a message on the WhatsApp that the quiz is uploaded. I don't know if you have created a WhatsApp group or not. It is not my responsibility. But if you have done that, mm,
I
mm,
have a question about questions.